From what I understand, he came in sometime after 2 again.
Last night?
What was he doing?
Huh, that's interesting. Because I received a text message from him saying he was going to bed early.
Court left at 12:30. I heard the door open, and it was. I know my other 2 roommates were out because one of them was not feeling good, and somebody opened the door at 2. And it was not next to me, and I know Alex was out last night.
Let's do this. Somebody want to donate a piece of paper? Pass it around. Everybody put their name on it. I'll give you a free 100% on a quiz for attending class.
I got it.
And this is strictly to punish Caruso. So he starts making showing up to class a priority. So why shouldn't the rest of the class benefit, right?
I like this.
Thank you. Somebody finally understands. Don't punish the whole class.
What's this?
I said, don't punish the whole class when one person isn't here. That doesn't teach that.
Well, the problem is we're kind of in between ideas here, so I don't really have like a legitimate quiz question to give you. So I'll just give you a free pass on a quiz, right? So make sure if you're here, you get your name on it. Oh, and by the way, just another kind of public service announcement. When we do have quizzes, even if you don't know the answer, turn a quiz in. Because what I do is I usually give at least a minimum amount of credit for you being here, as opposed to the people who got zeros because they weren't present. So if you don't turn your quiz in and I don't grade it, and the reason this is fresh in my mind is I gave a quiz yesterday and I just happened to grade it immediately following class. And there was 2 people who didn't submit the quiz, but I know they were there. So they just must have been clueless on the answer. Put your name on it, just say I don't know, and submit it and get 30% or something. Something that's not a 0.
You get points for being funny. Like if you don't know.
Potentially, it depends how funny. Yeah, it depends how funny. But the point is that I make a strong distinction between being here and being clueless and skipping class. You will get points. Yes.
Do you consider dad jokes funny?
Well, it depends how good of a joke it is, I guess.
Well, dad jokes are really dry and dumb, so most people don't think they're funny.
So why would you ask the question?
Well, I think they're extremely funny.
Hey, look at that.
Not everyone.
Isn't that terrible?
You and Mountain Dew again.
No. I mean the hand. Look at my hand shaking. No wonder all my numbers are messed up. That's all probably estrogen.
Probably one of your doctor wants to see you.
Seriously.
When you get to see him.
Tomorrow at 3, so I have to bail out of the afternoon class like maybe 10 minutes early. It's right up the street. I don't have to travel real far.
Yes.
Just a few minutes early. we're
having
having class.
Yeah.
I need enough time to get to my car and drive down the street for 5 minutes.
Did you have somebody go get your car and then you just jump in it and go?
Door-to-door service.
Yeah.
Okay.
Make Caruso make up the assignment to go get your car.
Seriously. Okay, so homework for this last class due today was to remove vowels, correct? So something we talked about last time, we did this little remove spaces, and if I remember correctly, didn't we have we even have it in here. We had a version of remove spaces where we replaced it with question marks. So one thought process, one pattern we want to have when we're dealing with strings, since we cannot directly remove stuff, and for those of you who did your homework and when you did your Google search, you found, this isn't this assignment, but a previous assignment. When you did a Google search and you saw something called string buffer and you used that, you got yelled at in your grades. Yeah, that comes from the finally somebody understands guy. Well, my name's on the sheet.
The dad jokes too.
So in any case, remember, I just kind of want to reinforce this. When I give you an assignment, I only want you to solve the assignment using tools I've introduced. I know some people who have had some more background in stuff, maybe know some things, but try to solve the assignment in terms of what we've done in class. I've been doing this long enough, I can pretty much tell from looking at somebody's code whether this is somebody who is taking this class because it's required versus, hey, I've never done Java programming before. So for those people, I typically will just give you a quick yell at, because I know it's sometimes difficult to separate what you already knew. But generally speaking, I want you to solve all the problems in terms of what you learned in class. I don't mind if you do Google searches to try to get you in the right direction, or text me and ask me to help you push you over the, the stumbling block you're dealing with. Several of you have taken advantage of that, and I would think that you've had some pretty decent experience with that, right?
Yeah.
Usually when you hit a wall, if you text me and just say, here's the problem I'm having, I can give you the fix in about 30 seconds via text message. So take advantage of that. But I don't mind if you do Google searching to kind of look at somebody else's code, but try not to just copy somebody else's code that's using stuff that you haven't seen before just because it works. Because you're only doing yourself a disservice. I want you to practice this stuff and learn from it. Okay? So punchline there is, the pattern that we're looking at here is that when we're dealing with strings, and I say remove something from a string, typically what should be going through our mind is strings are read-only. Once we create them, they're set. We can tack stuff onto them through concatenation, but we can't actually remove stuff from them. We'd have to build a brand new string. So what we want to think about doing is we want to think about keeping the things that aren't the ones that we want to remove. So rather than removing something, we're going to keep the other things. Okay? So, for instance, when we did remove spaces, what we did is we started with a fresh, brand new string that was empty. We spun through that string, and we only kept the crap that was not a space, rather than removing spaces. Does that make sense? Okay, so that's kind of a pattern that we want to kind of get into our mind for dealing with strings. Strings are read-only creatures. They're very powerful in Java. Now that we have this idea of string concatenation that allows us to accomplish a lot of things, but unless you're going to use a power tool, like for instance the thing that I mentioned, which I'm not officially introducing this, is something called string buffer. All that does is creates an object around a string that rebuilds a brand new string for you. It's just doing what we're doing anyways. It's just keeping you from having to do the logic work. So underneath the hood, it's still solving the same problem. Okay, so your homework assignment was to remove vowels, correct? Okay, we decided vowels were A, E, I, O, U. I guess I would have expected to do it upper and lowercase, but I don't necessarily care as long as you have the logic in there. Because strings aren't necessarily guaranteed to always be lowercase, correct? So what we're going to do, I'm going to just do it in lowercase initially just to keep the solution somewhat small. We're going to go ahead and we're going to have, I'm going to have a string. We'll call it temp. We'll start off as the empty string because whenever I'm going to remove something from a string, I'm probably going to be building a brand new string, only keeping the crap that I didn't want to remove. Okay? So then I'm going to loop through my entire original string. So again, this is a little pattern, the same loop we always write related to strings. All right, and we're going to go through here and we only want to keep stuff that are non-vowels. Now, one thing we can do is we can have a whole bunch of if statements. We can say if s dot char at I, that's the current character that we're looking at, if that guy is not equal to an A, then we might want to keep it. And it's not equal to an E, then we might want to keep it. Oh. And it's not equal to an I. We might want to keep it. And it's not equal to an O. And it's not equal to a U. If all those things are true, that means we don't want to keep that. That means this is something that we do want to keep. If it's not an A, and it's not an E, and it's not an I, and it's not an O, and it's not a U, we want to keep it. So we'll say temp is equal to temp concatenated with s dot char at I. Now, just as a quick side note here, remember those compound operators we dealt with? We can say temp plus equals s dot char at I. That is a legal, the plus equals compound operator does work for concatenation with strings. We're not going to use it here. I typically like to be as explicit as possible with code, especially when we're programming in class, but just more trivia knowledge that you can use that. All right. So if it's not a val, that's what this all this crap up here basically says that. If it's not a val, we're going to keep it. Now, we could write this in a couple of other ways. For instance, well here, let's do this initially. So when this loop is done, we can return temp. And the only thing we kept as we spun through I, or as we spun through S rather, is we kept things that were not either A, E, I, or U. All lowercase. So we only removed lowercase vowels in this case. Okay, so here is our string. We'll just use our blah as the initial version of this. And we will call remove vowels. So we should get this guy with the E removed, the O removed, the other O removed. And all the spaces should remain the same, correct? Okay, so there's one version of our solution. Now, if we wanted to take advantage of our newfound knowledge with methods, what we might do is we might write a method that detects whether a specific char is a val. So we might have a method that returns a Boolean. Maybe this guy's called isVal. He takes a char C as a parameter, and he returns true if C is not A, E, I, O, or U. That make sense? So we might say return all that crap, except instead of s.char at I, we're going to say C, the particular character we're checking. All right, so isVal is a method. This is a class method or instance method? How do you know? Static, because we're looking at the method definition. Okay, so this is a class method. How do we call class methods? Name of the class in which the method was defined. What's the name of this class? HW. All right, so the name of the method is isVal. It returns a Boolean, true or false. It takes a single character as a parameter. And this guy's going to return the result of this big, long, scary Boolean expression. What's a Boolean expression? An expression that boils down to a single value of true or false. So this guy looks scary because we have a whole bunch of ands in here, but this says return C not equal to A, and C not equal to E, and C not equal to I, and C not equal to O, and C not equal to U. Every single one of those guys needs to be true in order for this entire Boolean expression to be true, because we're dealing with ands. That make sense? All right, so that's our little isVal function, little isVal method. So now we can pass any character to isVal, and it will return for us true if it's a val, and false if it's not. Is that what this method actually does? What does this method do? It returns all of this. What is all of this? It's a Boolean expression, right? So it's going to return a true or false. My question for you is, does this method return true if the character we passed it is a vowel, and false if it's not a vowel?
Well, if it's not a vowel, it'll return a true value.
This guy returns whether it's not a vowel. This guy returns true if it's not a vowel, because that's what we were checking before, right? How can we modify this to return true if it is a vowel? I want two separate solutions. So I've given you a method that functions. This method works. It just logically does the wrong thing. It does the opposite of what we want. It returns true if we're looking at a non-vowel. I want it to return true if we're looking at a vowel. So what can we modify here to make this work? Go ahead.
Just change it from not to is.
So double equal sign? Okay, tell me why that won't work. Just making that one change. Well, you want me to do it for each of them. I get it. I understand. So assuming I go through and I make all the not equals equal, why will not work?
When you have to switch it to ors then.
Switch it to ors. So one solution here is we can do all of these guys as equal to. Equivalent to. This is the equivalence operator. And instead of being ands, we want these guys to be ors. So we're going to return true if it's an A, or if it's an E, or if it's an I, or it's an O, or it's a U. If any of those is true, not all of them, if any of them is true, because C can't be true for all of them, right? It can't be an A and an E and an I and an O and a U. That's a wasted Boolean expression. Okay, but if any of those guys are true, if it's an A, or it's an E, or it's an I, or it's an O, or it's a U, we're going to return true. Make sense? Okay, so now this guy returns true if we're dealing with a vowel and false otherwise. So now it's kind of compatible to the naming convention we used. This guy's, the name of the method is vowel. If you go to Home Depot and you buy a tool called isVal and you toss a character in there, you'd expect it to give you a positive result. A little green light flicks on, if what you fed it was a vowel, as opposed to the opposite of that. So now this guy gives us logically what we wanted. What would an alternative solution have been based on what we had there before? So give me a secondary solution based on what you already know in here. This is probably the best solution based on what you know right now. I'm going to show you some new things today. But based on what you know right now, this guy's probably our best solution. But give me a second solution based on what we originally had here with all the not equals and the and. Here, I'll even flip it back for solidarity's sake.
I would have just changed the method name to is not vowel.
Okay, we'll call that a weak third. That's a weak third solution. Okay, give me a stronger second solution. Right now, as you pointed out, this guy boils down to true if we're looking at something that's not a vowel. So if we currently have a Boolean expression that boils down to true for something that's not a vowel,
You could write down every other letter of the alphabet in that statement, but it'd take a lot longer.
okay. Significantly less of a cop-out solution than what he offered. Okay, but not a very good solution. We're going to call that an even weaker third solution, but a working one. Working one. He wants to put in every consonant, as well as every piece of punctuation, and everything else that's in the Unicode character set. So all 65,536 minus vowels. It's going to be rough. Working solution. But not a very good one. So, if I currently have a Boolean expression that boils down to true, if something is not a vowel, how can I turn that into a Boolean expression that boils down to true if something is a val? The solution I'm looking for does not require you to know anything else about the contents of that Boolean expression than what I just said. If I currently have a Boolean expression that boils down to true if something is not a val, how can I make it boil down to true if it is a val? Go ahead.
Or not operator.
Yeah, the not operator. I can just take all of this crap and just say, hey, whatever that is, return the inverse. Throw not in front of it. So that Boolean expression inside the parentheses boils down to true if I'm looking at something that's not a val. If I flip that, now it'll boil down to true if I'm looking at something that is a val. This is kind of crappy logic, but working logic, and way, way, way better than 65,520 whatever, and not a cop-out so people won't laugh at us. Just for changing the name of our method, right? Okay, so now we have a little method, although his original solution, so we'll give him a half a star. His original solution was decent. So now we have a method that will return true if we're dealing with a val. Okay? Well, what we could do now is we can come down and update our if statement down here. So instead of having all the scary crap inside of our remove vals code, all we have to say is hw.isVal s.charat I. If that guy is a val, what do we want to do with him? Move on to the next one, right? What if he's not a val? Now we're right back to his cop-out solution, but we use logic, right? So if the current character we're looking at is not, we're using the not operator, does not return true for being a val, then we want to keep it. That make sense? So that not operator can be a very powerful tool when we have something that boils down to one thing, but we actually want the exact opposite. It's a quick way of just providing the opposite. Okay? Not true is false. Not false is true. And we'll see we get the same output. Now, realistically speaking, I know we did a little bit of some weird stuff up here, but realistically speaking, is what we have right here any different than what we had there before? It's still the same code behind it, right? All we did is, this is called encapsulation. So what we did is we hid the details inside of a method, and that method lives up here. That make sense? So all the scary details are someplace else. That doesn't mean it's better or worse. But wouldn't you say that having an ability for checking whether something is a val or not might be handy? We might need to use that more than once. So if that's the case, it might make sense for us to throw that inside of a method. Okay, in this case, we're only using it once, so we really haven't gained anything. We've actually spent a couple of lines. But this is probably the cleaner way of doing it. Now when we look at our remove vals method, this thing reads a little bit more English-like, I guess, where we're saying if the current character is not a val, rather than having that big Boolean expression that you kind of have to walk through logically to figure out what it meant. But now, because of our method call, we're saying if it's not a val, keep it. See how the kind of the logic spells itself out a little bit better that way? Okay, and we can certainly expand this for the uppercase letters, right? Just with some more ands in there. All right. Now, let me remind me, have we talked about index of in here? Not in this class, I don't think, right? So here's our string toolbox. What stuff do we currently know how to do? We know about equals. I threw an equals ignore case in there. We know about char at. We know about length. We know about two uppercase. We know about two lowercase. I'm going to throw another method at us that's a very, very powerful method that we're going to use a lot. And this method returns an int. It's called index of. And it takes a char as a parameter. Okay? There actually is a second version of that method that takes a string as a parameter. Works the exact same way as I'm about to explain, but the one we're going to use often is the char one. But the string one, same logic applies. Just if you want to pass it something that's longer than one character, it'll work. And I'll explain this in a second. So we're going to add that to our toolbox. Now let's go talk about it. So index of. Here, I'll put the whole method header up here. Returns the first position in the calling string where C is found. Or -1 if C was not found in the calling string. What do I mean by calling string? Class method or instance method? Look it up here. This is the header of the method. This would be where the method was defined, correct? Is this a class method or instance method? Instance, how do you know? No static. Method definition, we don't see the word static, means it's an instance method. How do we call instance methods? Using an instance of the class in which the method was defined. So, I'm telling you this guy was defined inside of the string class. So we would use an instance of the string class to call this method. Something like s.indexUp, if s was a string, right? So if we said string s equals hello, and we said s.indexOf h, this guy would return a 0. If we said s.indexOf l, this guy would return a 2, the position of the first occurrence of the L. If we said s.indexOf z, this guy will return a -1, not found. Now, interesting enough, this -1 portion of this, from a problem-solving perspective, is probably the most important part of this method definition. We can use that idea of searching a string for something, and if it's not found, doing something in response. So that -1 becomes a very powerful thing. So it's important to understand the side effect of this method, that it returns the position in the string, the 0-indexed position in the string of the first occurrence of C, or -1 if it could not find it. That make sense? All right. So that's what this guy does. So as an example, let me just comment out these couple of things and I'll. So there's our string s equals hello, system.out.println s.index of h is going to print out a 0 because h lives at bucket 0 in s. So as index of searched through s, it ran into an h in the very first position. Okay, now this is case sensitive, as is most things in general purpose high level languages. So if I search for a capital H, what's this guy going to return? -1. Capital H is not found in this string. So that's how it tells me it didn't find it. Make sense? All right. If I search for an E, it's going to give me a 1. I found that at bucket 1 in the string. Remember, hello has 5 characters. Legal positions are 0 through 4. If I search for an L, it will give me the first place it finds the L. So using index of, we cannot find the second L. So index of is kind of a generic method for finding whether or not a character exists, not necessarily finding all characters. So that guy's at bucket 2. If I say, tell me where an O is, not a 0, an O, this will give me a 4. Kind of makes sense how index of works? Okay, so another little tool, ran to Home Depot, we bought this thing, threw it in our toolbox. So now we're going to start looking at some patterns we can use with index of to solve problems. So for isVal, we're going to update this method. What I'm going to do is I'm going to create a string. I like to call these strings map. You can name it whatever you want. You can name it elephant. So I like to call it map because what we're doing is we're mapping across it. We could also call it maybe search, something like that. And what I'm going to do is I'm going to fill this string with all the vowels. Okay? How could I write the Boolean expression that returns true if the character I passed in this case C, is not a vowel? Well, actually, in this case, I want it to be a vowel. So being a vowel means it's one of those characters inside of map, correct? How do I write the Boolean expression that returns true if C is found somewhere inside of map? Go ahead.
If map.index of would have to be A or E or I equals any of those any of the vowels, then it would be greater than
Remind me, what does index of return?
an integer.
An int.
If it's greater than or equal to 0.
Yeah, if it returns something that's not -1, then it means it found it. So if map.index of C is greater than or equal to 0, that means it found it, correct? What are we going to do then? Return true? Else return false? That logic makes sense? Now, somebody tell me why this if statement is actually redundant. Why can't I just return this line right here?
That's a Boolean expression, right?
It is. This is a Boolean expression.
And so wouldn't it just by the function of a Boolean expression return true or false?
Well, yes, but does it return the same true and false?
No.
Follow the code here. If I slow this down, if I resolve this in my head, I walk through the code. This says, if this is true, return what? If this is false, return what? Why don't I just return this? Does that make sense? Now, it's not wrong to write it this way, but it is redundant.
So will it display true?
Well, it's not displaying anything.
It's just returning.
It's returning it. So this asks the question, if this is true, then return true. And true comes firing out of here. In guy speak, it farts it out. Usually I get more laughs than that. 10 a.m., too bad, not good enough for fart jokes?
Yeah.
Well, it is Tuesday.
Today after Monday is almost worse than Monday.
Yeah.
Kind of like the week's well underway, but not well enough underway.
Not quite to that halfway point.
Thursday afternoon's kind of when we give up. That's everything just coasting into the weekend from that point on.
Friday pretty much is just not pay attention to.
That's right. Okay. So does that make sense, the redundancy of this? If you prefer the if statement version of things, if you like kind of walking through it and specifically saying, oh, I have to ask a question. So how do I ask a question? I use the if statement. If this is true, then return something. Else return something else. just because it happens to be the same value as the Boolean expression doesn't hurt anything. If this is the way that it makes the most sense to you, that's fine. Computers are fast. We're not going to notice a major performance difference. Eventually, you'll recognize, I'm kind of wasting my time here. I'll just return this. Okay? So right now, what I really want you to focus on as you're doing your homework is not trying to write super, like efficient code or in the shortest footprint possible. I want you to write code that you can follow. Code that makes sense to you. And if it happens to kind of be a weird solution, like Nick here writes a lot of weird solutions. Okay? But when you look at his code, you can kind of see that he like went down this like strange, weird wormhole with it, and this is what he ended up with, but he gets it. He understands why it works. Well, no, but I mean, but the thing is, as a professor, I kind of appreciate that because I can see his thought process. So even though the end result is a working, weird solution, it kind of makes sense. Make sense? As opposed to if you go and copy it off of Google and you have the solution that works and it's like super clean, but you don't necessarily know why it works, just that it works, that can be kind of dangerous. So if asking the question, if this is true, then return true, else return false. If that makes you happy, that's fine. You're not hurting anybody. Okay? So this will return true if something is a vowel, and this now works for uppercase vowels as well. So see how index of benefited us there? And if we did want to make this as clean as possible, we could just return that. Make sense? Now let me ask you this. Is that legal?
Yes. That's still a string.
Still a string. Index of is an instance method that was defined inside the string class. How do we call instance methods? We call them using an instance of the class in which the method was defined. An instance of the string class is anything that is a string. Is it true that this guy is a string? It is. In fact, we actually saved time. We didn't have to resolve the variable. We didn't have to turn map into this guy. Kind of make sense? So this would be even the more efficient way of doing it. That doesn't mean it's the better way from a beginning programmer perspective. Okay? Some of you have probably noticed on your homework comments that I make. I made it in class, but just kind of throwing things out there. If you've written if statements or loops where you don't use the opening and closing curly braces, I've commented on make sure you understand why you're not using the opening and closing curly braces. If you don't know why I'm harping on it, use the opening and closing curly braces. It's never wrong. Okay? It's never wrong to have an opening and closing curly braces associated with a for loop, even if you only have one line in there. It's never wrong to have an opening and closing curly brace associated with an if statement, even if you only have one line in there. Okay? I've been programming longer than every one of you in here. I can say that with confidence because I've been programming longer than anybody in here has been alive. So, given that, I still use the opening and closing curly braces because I like the way it formats my code. Okay? And I promise you I know the difference. So I would encourage every one of you to always use the opening and closing curly braces. I think it just produces more readable code. But I don't care if you don't use them, but if you're not going to use them, make sure you know why you're not using them. Just because it works, that's not a good enough reason. Because you might have just lucked out. Can that make sense? All right. So here's a method that checks for our vowels in a fairly clean way, and we can see how powerful index of is, right? Could we write an is consonant version of that pretty easily? Could we write a is digit version of that pretty easily? Put 0 through 9 inside of a string. If it's one of those guys, it's a number. It's a digit. If it's not, it's not. That makes sense? So index of is a very powerful tool for us. Okay, Let's throw a couple of other tools in our toolbox. And actually, these are tools I typically don't give students quite yet, but I think you're ready. So here's a method that returns a string. It's called Substring. And one of the, actually, if you'll allow me, let me start a different slide for these methods. Let me kind of put it down here towards the end. More string methods. Real quick here. Just throwing a little curveball out here. One thing you could have done is you could have used 2 lowercase or 2 uppercase. So you only needed to check lowercase or uppercase vowels. So you could have used that method to kind of leverage things for your assignment. So more string methods. We have a method that returns a string called substring. And there's a couple of different versions of this method. One of them takes in an int. Here, I'll call it int begin. There's another version of this method that takes an int begin and an int end. Make sense? Now, what int, so first of all, what's this an example of? What funny word is that an example of? Polymorphism. More than one method with the same name but a different number and or type of parameter. Polymorphism. So string class has 2 methods called substring. One takes 1 int, the other one takes 2 ints. The one that takes 1 int, what it does is it returns, and again it's an instance method, right? Because the static word is not there. So what it does is it returns, just write this in there, this returns a string that starts with position begin and goes to the end of the calling string. Okay, let me show you that as an example. So we have our string hello here. I'm going to say s dot substring. Oh, here, I accidentally clicked on the wrong one. It should be both of them. So here's the begin one. I'm going to say bucket 2. So this is going to give me everything from bucket 2 on. So that's 0, 1, 2. So here's bucket 2. So it's going to give me everything from that position all the way to the end of the string. So this is just going to be LLO is what s.substring2 will give me. Make sense? Now, it did not permanently change s. All it did is it took the calling string here, the guy that called this method, and produced a brand new string that was everything from bucket 2 on, including bucket 2. What if we say 0? We wasted time in a very fancy way. It's like, I want to call the substring, but just give me everything. Everything from the beginning all the way on. All right? So that's one version of substring. The other version of substring returns a string that starts with position begin and goes to position end non-inclusive. So it does not include whatever's at bucket end. So it goes from to end -1 in terms of inclusive buckets. So this allows you to get a piece of a string somewhere in the middle or something like that. Good. So let's see how that one works. So I'm going to go from bucket 0 to bucket 2. Set this as a comma, not a period. There we go. So that's going to go from bucket 0 inclusive to bucket 1 to bucket 2, but it's not going to include bucket 2. So this is going to boil down to the string he. Make sense? So those two different substring methods allow us to get pieces of a string. So let's say we wanted to write a method that takes a string as a parameter as well as a char. And we want this guy to return a string. Let's see. Return the first part of the string split on C. For example, if we had the string hello world and we split it on the space, this guy should return hello. Make sense? If we split it on the O, well, that's probably a bad example. We're going to roll with it now. We split it on the O. I think this is a Christian worldview, maybe. What's our result going to be? Be hell, right? The first O, not the second. Make sense? If we split it on the R, we would get hello space whoa. So we live in a different world now. I have to be careful with my examples that they aren't phrasing. I just learned that word last year. Phrasing. All right, make sense? What this method's supposed to do? All right, how would we solve this problem? Well, I want to split this string, S. Now, why don't I have a calling string in this case? Why do I have to pass it both values? Why do I have to pass it the string and the char that I want to work with? As opposed to when we're talking about all these string methods over here, where I can use this phrase, the calling string. I didn't use it there, but you know what I'm talking about. Here, return the first position in the calling string where C is found. Why am I able to do that with our string methods, but I'm not able to do that with our methods that we're writing here? It has to do with the difference between instance methods and class methods. All the string methods are instance methods. And how do we call instance methods? We call them using an instance of the class in which the method was defined. So that method, an instance method, knows about the instance that called it. So if we have a string method and we call it with a string, that method knows about the string that called it. That make sense? It knows of that guy. In our case, we're writing a class method. How do you know this is a class method? Static. We know it's a class method because we're defining it right here, and we put the word static in front. Since we call class methods using the name of the class in which the method was defined, we are not aware of any calling guy, because he was called by this generic class name. So we need to pass it all the information that it needs to work. We can't rely on it having any pre-existing information. That make sense? So we write this method, if we wanted to give us a substring, if you will, we need to pass it the string that we're going to split up, as well as the character that we want to split it on. because we're writing the method ourselves as a class method. Later on, when we start writing our own objects and we start writing our own instance methods, that may change. All right, so how do I return a string that is a portion of S split, the first portion of S split on this character? Well, let me ask you this first. What should we return if C is not found inside of S? The whole string? I'm splitting it on a Z and I didn't find a Z. I should probably return the whole thing. So how do I determine if S contains C? Index of. So I might want to create a variable, maybe called pos, and I might want pos to be equal to s.index of C. So now right now pos holds either the first index where C was found inside of S, whatever char is stored inside the variable C. Okay, so the first pos of the first position in S where C was found, or it holds a what? Either holds the first position or what? Negative 1 if it didn't find it. So if it holds a negative 1, what do I want to do? Negative 1 means I didn't find it, therefore, okay, so I'm going to ask the question. If pos is equal to negative 1, if that's a true statement, just return S. If we are still kicking, that means pos is something other than negative 1, correct? So I call this kind of like a minefield. So we hit this very first stumbling block and we got past it because pos actually held a value that was not negative 1. So if we're still kicking here, we know that pos is a legitimate place in the string. Make sense? Otherwise, we would have already returned. And what does the return statement do? What does the return keyword do?
Store some information. So it's not just lots.
I'm going to start off by saying no, but I'll let you explain. What does the return keyword do?
I mean, it allows it so you can call that information again, because if you didn't have return, then it's just like you go through the functionality of it and then it's done. It's no more.
Well, that's what a method that has a return value is. So in this particular case, we have a method called split on char that advertises that it returns a string. So this guy will boil down to a string, and if we choose, we could store that string someplace up here. But what does the return keyword itself do? What does that guy do? What are the properties of that guy?
Doesn't it kill the method?
It does kill the method, but before it kills the method, what does it do? This guy and this guy work in conjunction. If I have a method that advertises it's returning a value, that is something is here other than void, the return keyword is the means by which we have this method return that value. How we have that value fire out of here, that we can choose to catch it someplace else, wherever we're calling the method. This is the method definition. So the return keyword forces this method to end, and its final act before death is to return this value, whatever that is. And the rule is going to be that this value must be of the same type as what we've advertised this guy boils down to. Make sense? So return makes a method immediately end, returning the value following it. So if we hit this, we know our method is over. Make sense? So if we're still kicking here, that means the method did not end. So not every if statement makes a method end. Just this particular one because it has return inside of it. You know, if we did this instead, Whoops. We notice that's a -1, and all we did is print out whoops. We're always going to get to this line. The only question is whether or not whoops gets printed out to the screen, right? So this method's still going. And now I might have a -1 to deal with. But by having that return statement there, we are guaranteed, I'm sorry. Why can't I do that, first of all? I need to return a string. Okay, so I put in the -1, which is what pause holds if I'm in there. So I'm going to return S. The entire string, because the value you asked me to split it on is not there. So if I'm still kicking here, I know that I have a splittable string. Correct? So how do I split the string and return the appropriate value? Remember, I want to return the first half. So I'm asking you to take your knowledge of substring and use it in a interesting way. So if I'm still here, I know pause holds a real number, something other than -1. A number between 0 and, well, 0 and s dot length -1, right? 0 and s dot length -1. And I want to return that guy.
Else return s dot substring 0, pause.
Return s dot substring. Always start at 0 because we want to return the front half, and we want to go to pause because that's the position where the character we're splitting on is, and we don't want to include that character. Correct? Okay, will that do it? What if the character we're splitting on is the very first character? Question is what happens if I return the substring 0 to 0? Because remember, this is non-inclusive, right? So this is saying give me everything from bucket 0 up to, but not including bucket 0.
Pause +1.
Well, before we get to that, what's the result of this line going to be? What do you think? You think the empty string? So either the empty string, what about maybe an H? Maybe an error? It is the empty string. Okay, so built into substring, it handles that special case where we try to take a substring from the beginning to a bucket that is also the beginning. It handles it as cutting off that first character. All right, so this will return for us the substring from bucket 0 all the way up to, but not including pause. So if pause happened to be bucket 0, this would return the empty string, which is what we want, right? If I had hello world and I wanted to split it on an H, everything that came before the H was nothing, the empty string. Otherwise, I'm going to split it from 0 to pause -1 inclusive. So by saying pause, and because of our knowledge of how substring works, where it gives us everything up to but not including pause, we'll get the first half. Make sense? So we'll go ahead and call our method. We'll say hw.split on char. We'll pass it s. And we'll pass it the, let's give it the first L. So I wanted to take the string S and I want to split it on the L. That is, give me everything up to but not including the first L. So it should give me an HE. Correct? Okay. And now I'm going to trick you, so I'm going to say, give me everything up to a O. What's the output of this program going to be? I run it, nothing. Well, what if I put in the L like we had before? Is the output E or he? Nothing. Remember I said I was tricking you.
Oh, no. I didn't even see that. You're not printing it.
Not printing anything.
You're just telling it to do it.
This method returns a value, correct? That's what this return statement does. So it returns a value. I either hit this return statement, and if I still was kicking after this guy, then I hit this return statement. If we advertise that the method's going to return a value, we must guarantee that a value is returned. Okay? This guy does not return two values. Remember, the return statement makes a method immediately end. So I either returned here or I returned here, but not both. But ultimately, this guy will boil down to a string. So this guy right here boils down to that string. And what am I doing with that string? I'm doing nothing with it. So maybe I do something with it. Now what's the output going to be? Still nothing, but I did something with it. Stored it somewhere. So I can use it later if I want, but I never actually displayed it. Understand the difference? So displaying something and returning something or storing something are very different things. Now, if I want to display it, I can display whatever's in the variable result, which is what was returned by my call to split on char. That make sense? Now, what if I want to write a method did I spell occurrence? 2 R's? 1 R? Is that right? Let's just assume yes.
Yeah, 2 R's.
So what if I want to write a method called remove first occurrence that takes a string as a parameter and a char. And what I want to do is I want to return a new string that is the original string with only the very first occurrence of C removed. The entire rest of the string is intact. So, for example, if I were to pass it HELLO and I wanted to remove the L, this should return HELO. I only removed the first occurrence of that. Make sense what I'm asking? For homework, write that method. You have all the tools in your toolbox to solve that problem. I'll go ahead and put that up on Angel. And we'll stop a couple minutes early, I guess. Any questions about any of the stuff we covered today? Now, just quickly, since we do have a few minutes left, just talking about the assignment a little bit, give you a little hint. I only want to remove the first occurrence. So right off the bat, I've said I'm removing something from a string. What should we start thinking about? Keeping the rest of the stuff, right? So rather than removing something, we want to think about keeping everything but the very first occurrence of C. The very first thing that goes through your mind. Then we want to start thinking about the tools that we have available to us. We can do substrings. So one possible thing we could do here is maybe get everything before, get everything after, concatenate them together. Right? That's one way we can solve it. We can find the position of the first occurrence. Correct? Using index of. Then we can get the substring from that guy, from 0 to that guy minus 1. Then can't we get the substring from that guy plus 1 to the end? And then glue those together? We could. Is that the only way to solve this? Could we also start at bucket 0 and just start building up a string until we hit the very first occurrence of C? Then stop, remembering where that was, and then have a second loop that starts one bucket later and builds up the rest of the string? Can we do that as well? So 2 separate loops, one that builds everything up to the first occurrence, which we can find with index of, and one that starts one character later and builds up the rest of the string. So what we're having to avoid here is the idea that we have multiple occurrences of C, the potential that we have multiple occurrences of C, because we only care about the very first one. And it just so happens that we have a tool in index of that allows us to find only the very first one. Okay, make sure it makes sense what I'm asking. Kind of have some ideas on a couple different ways we can solve this. I don't care which of the 2 ways. You can use our new tool, Substring. That might be a decent way of solving it. But either way you cut it, you're going to use index of and write your own loop. I would say either way is kind of similar solution. All right, I'll see everybody on Thursday.